All right, this problem, stoichiometry problem, our starting point has changed. Our end point is still grams of some reagent or product. It can be anything. So again, we can go left to right, right to left. That's the beauty of the math method, is you just need to know two things. One, where you started, and in the reading of the question, maybe it says that you have 1.12 moles of aluminum. So you put it right underneath aluminum in the map. And then if it asks for the grams of copper, you put that up high because, again, moles are down below and grams are up high. And we need to know grams of what? So in the question, it would have said, I want grams of copper. Again, we could have put grams of aluminum sulfate as the goal, but it didn't say that. It will say in the question. So we set up a map. We always have to have the balanced equation. So you notice we do have to consider coefficients more in this case compared to other problems we've looked at. We have 2 of the aluminums, 3 of the copper sulfates, making 1 of the aluminum sulfates and 3 coppers. And you say, well, how does that work out as far as balancing? Remember, we always consider the SO4 as a unit complete, like 4 tires on a car. That's a whole car. So that's the SO4, and we have 3 of them. So we better have 3 of them over here, and we do. So that's an easy way to do your balancing very quickly if you have these polyatomic ions. Don't worry about the O and the S individually. Take it as a whole. So 3 coppers, 2 aluminums, 2 aluminums. This looks balanced and ready to roll. Let's deal with the question. Well, to go to that question mark of grams of copper, I have to go mole to mole, keep it horizontal, and then I have to consider my final arrow up. So this is only going to have 2 conversions. If you were to show it in dimensional analysis, if you're doing it that way, you would have 2 conversions. But we're using the map method here. So I know whenever I'm going mole to mole, it's all about the coefficients. It's only about the coefficients. No molar mass is used when these lines are level. So I'm leaving the 2 and I'm going to a 3. Leaving was low, we were sad, and arriving to that 3, I guess glad to be home. So that's a journey. We're leaving the 2. And don't use, again, the molar mass. We're already at moles. You don't need to use the molar mass. You're at moles. You're converting mole to mole. And then you're going to multiply, just like you did in the last video where you're going up an arrow. If you're going up, we're multiplying by the molar mass. So in this case, the copper is 63.55, we'll say, just to keep it simple, grams per mole. So let's do the math. I have my calculator this time, and I'll set it, I guess, right here and just give you the numbers. So the 1.12 moles, 1.12, we're going to times it by the 3, and then divide it by the 2. Gives us 1.68, and that's about right. We don't double this, but we have a greater number on top, dividing by a smaller number, so it should be a little bit larger. And then we're going to multiply that by the 63.55. And we get 106 point, let's say, 8 grams. It should be, again, right underneath this, because that's what it represents. It represents the copper, how much we make from 1.2 moles of aluminum. This is, again, how we do problems involving stoichiometry using the map method. Does it have to be used? No. You could have started if you really wanted to, and I'll just put it below. It's kind of like option B. And many students kind of mix the 2 methods, so they'll say, I know I have to start off with 1.12 moles, but if you're using the dimensional analysis, you must show your units. We said there were 2 conversions. Put a little kind of divide between the map method and the dimensional analysis. It's 2 conversions because we had 2 arrows, so I had to do and I'm just for sake of space, you have to put moles of aluminum, 3 moles of copper. You have to show your units because this is not with a map. This is with a map. No units, units for dimensional analysis. And then you'd have to have 1 mole of copper is equal to 63.55 grams of copper. And that would give us our same answer of 106.8. One of these two methods you must use in class, but sometimes, again, students see it better with the map, and then they just kind of write it using dimensional analysis. Or skip either one. Use one that you like, just pick one, because it's all about practice. Practice, practice, practice. Thanks. Bye-bye.